Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we'll be doing Unit 10, Lesson Number 1, Graphical Displays of Data. Before we begin, let me remind you that you can find a worksheet and a homework assignment that go along with this video by clicking on the video's description, or by visiting our website at www.emathinstruction.com. As well, don't forget about those QR codes at the top of every worksheet. You can scan those codes with your smartphone or with your tablet, and it will take you right to the video associated with the lesson. All right, let's begin our unit on statistics. So, statistics is all about doing studies, collecting data, and then understanding how that data looks. And one of the things that we want to do today is understand some of the most basic ways that we display data that we've collected. All right? And one of those ways is with what's known as a dot plot. So, let's get right into dot plots. You've probably seen these before in middle school classes, maybe even as early as elementary school. Here we've got Charlie's Food Factory, and they currently employ 28 workers whose ages are shown below on a dot plot. Answer the following questions based on this plot. I bet you can certainly do letter A, so let me pause for a minute, and you can pause the video to try to answer that question. All right. Well, letter A simply asks, how many of the workers are 18 years old? Well, that just goes to how you read a dot plot. The 18 is right here, and there are 1, 2, 3, 4. There are simply 4 workers that are 18 years old. I like it. That's pretty easy. Now, letter B gets into a more complicated piece of terminology, and one, unfortunately, that we've already seen in this course referring to a totally different thing. Letter B asks, what is the range of the age of the workers? Now, that's really tricky for a variety of reasons. Number one, because we've already seen range, and it's referred to the outputs of a function. That's not this, right? A lot of times people use range in terms of the real world by saying, well, hey, the youngest person is 16, the oldest person is 42, so the range is 16 to 42. But unfortunately, in statistics, range has a very specific meaning. It is the highest value, I was going to say the maximum, and that would work well as well. It's the highest minus the lowest value. All right? The highest value being 42 years, and it does have units, the lowest value being 16 years, and so we simply subtract that, and the range is 26 years. All right, 26 years. Now letter C. Would you consider this distribution to be symmetric? Right? We've seen symmetry before in terms of parabolas. Symmetry basically means it looks the same on one side as it does on the other. And the answer here is most certainly no, right? What we would say is it trails off to the right. A symmetric dot plot would look something like this. So a symmetric would sort of look the same on either side. It would kind of look a little bit like this, right? This thing certainly doesn't look that way, right? It would look the same out here as it does out here. Letter D. The mean, the average age for a worker is 22 years old. So we'll talk about averages and means in a future lesson. But this one I'm just telling you, I've calculated it. The average or mean age is 22 years old. Why is this average not representative of a typical worker? That's interesting. Right, well, let's find the mean. Here's the mean, 22. All right, the mean. Now, very often we use averages / means to represent a typical data value. Okay, it's what's called a central value or a central tendency value. All right. But here I'm claiming that it's not representative of a typical worker. Why do you think that is? All right, well, let's take a look. What strikes me is that there are a lot of workers down here, lots of them. That kind of makes sense. This is probably a fast food place. I don't know, Charlie's Food Factory. It's probably out in the Midwest or something. There's lots of workers down in here, right? And if that's really representative, then we'd expect sort of the same number of workers up here as down here. But there are only 1, 2, 3, 4, 5, 6, 7. There's 7 up here. Of course, there's 1 right here. And that means there's 20 of them here, right? Because I got 28 overall. So there are way more workers younger than 22 than older than 22. So that's why it's not representative. Eventually, we'll talk about the median of a data set, and that would be way more representative here. But for right now, we're just trying to get a feeling for how we display data on graphs and how we read graphical displays of data. All right, well, I'm going to clear this out. Write down anything you need to. Okay, here we go. Let's take a look at the next page. All right, well, let's actually do a dot plot now. They're pretty easy, all right? It says a farm is studying the weight of baby chicks after 1 week of growth. They find the weight in ounces of 20 chicks. The weights are shown below. Construct a dot plot on the axes given. So this is pretty easy, okay? And by the way, I think I maybe only have 19 here. My apologies on that. But it's as simple as this, right? We've got one at 2, another one at 1, another one at 3, another one at 4, another one of them at 2, another one at 2, another one at 3, another one at 1, another one at 5, another one at 3. Bit mindless and maybe tedious, but we're getting the job done. These days, most statistical plotting is, of course, not done by hand, right? It's done by using computer programs. Whoops, there goes my 5. Probably the most common of which is what's known as Microsoft Excel, all right? But there's many other ones, okay? And they can make these kind of plots for you. Of course, actually what I found is that it's somewhat hard to make a dot plot on Microsoft Excel, but it can be done. All right, and there you go. By the way, this would be a distribution that would be considered mostly symmetric because it more or less looks the same out here as it does out here. There's a little bit of asymmetry, but it's mostly symmetric. I know that the problem didn't really ask that, but it's good to kind of point it out. Okay? All right, I'm going to clear this out. We just wanted to do a little bit of practice on a dot plot. It's pretty darn easy. You'll get some practice with that in future lessons and on the homework. All right, here we go. Let's take a look at another type of representing data, and this is way more common than a dot plot. Here, we're going to talk about a histogram, okay? Now, you've seen histograms before. You've certainly seen them in previous classes, and you will see them in newspapers. You'll see them in reports. They're ways of representing how much of the data set falls within a given interval of values. Sometimes those intervals represent only one value, but more often than not, they represent multiple values. So for instance, and I bet you can read one of these immediately, this is showing the same data that we had before, the ages of workers at Charlie's Food Factory. And take a look at question A. It says, how many workers have ages between 19 and 21 years? And that includes the 19 and the 21, by the way. So how would you read this? Pause the video for a moment and tell me how many workers are between 19 and 21. All right, well, we need to be just a bit careful, but it's not that bad, right? Here's our 19 to 21 category. If I go over here, it looks like 11. Now, I love histograms, and we'll talk in letter C about why they might be a little bit better than dot plots, but in letter B, there is a big disadvantage of a histogram compared to a dot plot. What do you think it is? All right, well, here it is. You don't know what any, and this is key, any individual data value is. Right? You don't know what any individual data value is. In fact, for all I know, these 11, they could be all 20 years old, right? All we know is that they're 19, 20, or 21, right? We don't know. We don't know how many 19s there are, how many 20s there are, how many 21s there are. We just know that there are 19 people who have ages 19, 20, or 21. So we lose information with a histogram that we have with a dot plot. And yet histograms are a lot more common than dot plots. Now why is that? And that goes to letter C. Does the histogram have any advantages over the dot plot? Think about that. And you may want to look back, sorry, I don't have it on the screen, but look back at the dot plot from exercise 1, right, versus this. There is an advantage to the histogram. And that advantage is that it is easier to read the total amount in each category, right? It's easier to read the total amount in each category. Right? With the dot plot, you literally have to sit there and count the dots. All right, now granted, you could have a Y scale on the dot plot, but that's not all that common. Really, with the dot plot, what you're tending to do is just looking at the number of dots and saying, oh, well, there's more dots there than there are there. So there's more people that have ages of 17 years than ages of 30 years, right? That's what you're trying to do with the dot plot. The histogram, and why it's used so much more often, is that it's very fast. You can look and you can immediately say, oh, well, the number of workers that are between 16 and 18 is 9, right? It's very, very obvious very, very quickly. It's also very obvious from this that there's a lot more people that are younger working at Charlie's Food Factory than older. Although one could say that you can certainly do that as well with the dot plot. Okay? So pause the video now if you need to, then I'm going to clear out the text. Okay, here it goes. All right, let's keep working a little bit with histograms. The last thing that we might want to be able to do is just construct a histogram. Now again, I wouldn't put it past a standardized exam to ask you to construct one of these things, even though the vast majority of the time now, when histograms are made, they're made with computer programs, and that's what you really should be doing. You should be making histograms on Microsoft Excel or some other spreadsheet program. But let's take a look at how to do one by hand. So, exercise number 4. The 2006-2007 Arlington High School varsity boys basketball team had an excellent season, compiling a record of 15-5, 15 wins and 5 losses. I still remember it. The total points scored by the team for each of the 20 games are listed below in the order in which the games were played. Okay, so the order in which the games were played, not in numerical order. We want to create a histogram for that. Now there's a lot of different nitpicky rules about histograms. Your teacher might have some. Common Core standards are actually very, very vague about them. They don't really tend to lay out things like that. But one of the things that certainly is true about most histograms is that you want each category to be of equal width. Because if it's not, it can be very deceptive. If you've got one category that's really small, one that's really large, then it'll look like there's more in one category than the other. So notice here what we really have is we have 10-point categories from 40 to 49 points, 50 to 59, 60 to 69, 70 to 79. And all we're going to do is go through and say, all right, I got 76, so that's one in here. Then I have a 55, so that's going in here. Then I have a 76 back in here. Then I have a 64, that one goes here. A 46, we'll put that one here. A 91, that's a high scoring game. A 65 goes here. A 46 is going to go here. A 45 is going to go here as well. A 53 goes here. Real defensive battles on some of these. 56 there. I got to not do all these side conversations, otherwise I'm going to botch it. 57, we'll do that. 67 is going to go here. 58 is going to go here. 64 will go down here. A 67 will also go in this category. A 52 goes up here. A 58 goes up here. And a 62 goes down here. All right. The frequency simply refers to how many fell in each category. So 3 fell in here. 8 fell in here. 6 fell in here. I'm just making sure these were my original counts. 2 in here, 0 in here, 1 in here. All right, so now we want to construct the histogram. All right, I'm going to give myself a little bit of a y-axis with gray. We'll go blue again with my line. It just makes my life easier if the computer does it instead of me. All right. And we would want to label that. Now, it would be actually fairly hard for me to turn the paper right now. But what we want to do here is we want to label it as either, I think, something nice and descriptive, like the number of games. I cannot believe I'm trying to do this. Wow, sorry about that messiness. I was actually writing vertically, not easy. Now down here, right, we'd like to spread this out sort of as much as we can, all right? And yet we start at 40. Now, traditionally in New York State, if the x-axis doesn't start at 0, you're supposed to put in what's known as a line break, all right? Something like that, okay? I don't really particularly believe that you need one. Okay, if you use a professional spreadsheet program, I guarantee it won't put one there. So those line breaks either kind of look like a little thing on a heart monitor, or you can do kind of like a double line like this. I'm going to put one in there because, again, it's tradition in New York State to do that. Whether it's a tradition that makes sense or not, I don't know. And you should find out from your individual teacher whether they expect you to have one there. Okay? But we'll have it there, and then we'll start this at 40. Now, how many squares should we make each one? Well, we've got 1, 2, 3, 4, 5, 6 categories. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 boxes left. Looks like I'm going to get rid of that 40, sorry for right now. Looks like I can afford 2 boxes per category, so that's going to be my first category. 40 to 49, my next category. 50 to 59, my next category. 60 to 69, the next one. 70 to 79, the next. 80 to 89, and the next one. 90 to 99. All right, well, if there was some reason to make this go by 2s or 5s or 10s, we would, but the largest frequency we have is 8, so we might as well just have those go by 1s. 1, 2, 3, 4, 5. Maybe just do something like this, 6, 7, 8, 9, 10, right? 40 to 49, we have 3, so that means I'm going to have a rectangle that looks like that. I'm almost tempted to use my rectangle utility. My next one, 50 to 59, is at 8. That's going to be right here. All right, 60 to 69 is at 6. Boy, I tell you, a ruler would be nice right now. 70 to 79 would be 2. 80 to 89, that's 0. And 90 to 99, 90 to 99, that's 1. A lot of students like to add in shading, cross-hatching, something like that. I think that makes it look good too. All right, some students get very creative and they put like different shading per rectangle. I think that's always nice. Get creative if you'd like. But there's our histogram. My hope is that you wouldn't have to construct one of these by hand on any kind of standardized test. Quite frankly, again, if you ever have a job or some kind of a situation where you have to construct histograms, I pretty much guarantee you're going to be doing it using a computer. What you really want to be able to do is read a histogram, be able to look at one and immediately know the kind of information it tells you. Okay? But still, getting a little practice in drawing one by hand doesn't hurt. All right. Copy down what you need to, and then I'm going to clear out the screen. Okay, here we go. Let's finish up. So, statistics is all about collecting data and understanding what that data tells us about a variety of different things. Perhaps it's a doctor collecting data about how well two drugs work in helping you lose weight. Perhaps it's just somebody collecting data to figure out, right, how many points a basketball team has scored. In today's lesson, all we really did was look at two primary ways of representing data distributions: the dot plot and the histogram. We'll also see some other types of plots in future lessons, but that's it for now. And for now, let me thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.